Welcome to Ask and Learn.
So in this question, we're asked to construct truth tables to 6 different compound propositions that are given to us. Let's start with the first compound proposition. So A, which is P, conditional statement, negation of Q, inclusive or R. So by looking at this compound proposition, we know that we will have 4 individual propositions. We have P, we have negation of Q. We need Q to find the negation of Q, so that's 3 propositions, and we have R. Let's start by writing down each individual propositions. So we have P, we have Q, we have R, and we have negation of Q. So let's write the truth values for each. So here we have true, 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 false, 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 false. For Q, we have true, true, false, false, true, true, false, false. And R we have alternating, so it's true, false, true, false, true, false, true, false. And we know that the negation of Q truth values are the opposite of the Q truth values. So here we have true, true, so that's false, false. Then we have true, true. Then we have false, false, true, true. Now we'll write this compound proposition to write down to find out the truth values. So it's negation of Q, inclusive or R. So we know with the inclusive or, if both proposition truth values are false, then it's false. It'll be true otherwise. Therefore, we're looking at the fourth and the third columns. So false, true is true, false, false is false, true, true is true, true, false is true, false, true is true, false, false is false, true, true is true, and true, false is true. Now we'll write down the complete compound proposition. So that's P, conditional statement, negation of Q, inclusive or R. So we know that for the conditional statement, if the first proposition is true and the second proposition is false, then it'll be false. It'll be true otherwise. So now we're looking at the first column and the most recent column that we did. So true, true is true. True, false is false. And we have true, true, which is true. True, true is true. And then we know if the first proposition is false, no matter what the second proposition is, it's going to be a true truth value. So since the next 4 P's are false, we could just write the next 4 are true. 1, true, 2, true, 3, true, 4, true. So this will be the truth table for A. Now let's get rid of these columns to solve for B. Let's get rid of this. And now we write down what B is asking. So B is the negation of P, conditional statement, Q, conditional statement, R. So here we also have 4 individual propositions. We have 3 written down here. Now we need just to write the 4th, which is the negation of P. So the negation of P, we know the negation of P truth values are the opposite truth values of that of P. So first 4 are true, the second 4 are false. So negation of P will be opposite. The first 4 will be false. 1, 2, 3, 4. And the next 2 will be true. True, 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 true. Now we will solve this compound proposition first. So we will write Q, conditional statement, R. Now we know again that the conditional statement, if the first proposition is true and the second proposition is false, it'll be false. It'll be true otherwise. Therefore, we'll be looking at the second and third columns. True, true is true. True, false is false. False, true is true. False, false is true. True, true is true. True, false is false. And the next two are true, since they start off with false. Now we will write the complete compound proposition. Negation of P, conditional statement, Q, conditional statement, R. Now again, we know that for the conditional statement, if the first proposition is true and the second proposition is false, it'll be false. It will be true otherwise. So now we will look at the fourth column and the fifth column in order to solve for the truth values. Therefore, we could see that the first four start with false. We don't have to look at the second proposition since we know this will automatically make the truth value true. So true for the first four, true, 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 true. Now, true, true will be true. True, false will be false. And the next two will be true since it's all trues. True, true. So this will be the truth table for B. Now let's get rid of some columns in order to solve for C. Delete that. Now we know that C is P, conditional value, Q, inclusive OR, negation of P, conditional statement, R. Now here we have four individual propositions as well. We have three written down here. We need to write the fourth, which is the negation of P. So write that down, negation of P. And again, the negation of P truth values are opposite of the truth values of P. So this will be false, 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 true, 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 true. Now we'll write down the first compound proposition, which is P, conditional statement, Q. Now again, for the conditional statement, if the first proposition is true and the second is false, it'll be false. It's true otherwise. So we look at the first two columns. So true, true is true. True, true is true. True, false is false. True, false is false. False, true. The next four are falses, so it's all true. True, 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 true. Now we'll write down the second proposition, compound proposition, to solve for that. Negation of P, conditional statement, R. Now we're looking at the fourth column and third column. Again, if the first is true and the second is false, it's false. It will be true otherwise. So the first four here start with false, so we know that that's automatically true. True, true, true. The next four, true, true is true. True, false is false. True, true is true. And true, false is false. Now, all together, we have P, conditional statement, Q, inclusive OR, the negation of P, conditional statement, R. Now we know that with the inclusive OR, if both of the propositions are false, it'll be false. It'll be true otherwise. Therefore, we're looking at true, 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 false, true, false, true, 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 false, true, 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 false. None of these combinations are both false. So all the truth values will be true. 1, 2, 3, 4, 5, 6, 7, 8. So this will be the truth table for C. Now we'll delete some columns and solve for D. Now before we do this, let's write D. We know that compound is very similar to C. The only thing that changes is the inclusive or changes into the conjunction or and. Therefore, we could leave all our columns except the last one. We'll delete this. And now we'll just write the correct compound proposition. So this compound proposition reads as P conditional statement Q and negation P conditional statement R. So we found the truth values for each individual proposition and each individual compound proposition originally for C. Now we solve the truth values for the compound proposition given in D. Now we know that the and means both propositions need to be true in order to be true. If either one is false, or if they are both false, it'll be false. So now we look at true, true is true, true, true is true, false, true is false, false, true is false, true, true is true, true, false is false, true, true is true, true, false is false. So this will be the compound, the truth table for the compound proposition given in D. Now let's erase some columns to solve for E. So erase these. Now we know that E is this compound proposition. P, biconditional statement, Q, inclusive or, negation of Q, biconditional statement, R. So looking at this compound proposition, we know that we have four individual propositions. We have P, Q, negation of Q, and R. Here we already have three of them written. Let's write the fourth, which is the negation of Q. Again, the negation of Q truth values are the opposite truth values of Q. So we're looking at Q here, and we write the opposites. So it will be false, false, true, true, false, false, true, true. Now we'll write the first compound proposition. So it's P, biconditional statement, Q. So the biconditional statement really means that both truth values of each proposition needs to be the same in order to be true. If either one of them differs from the other, it'll be false. So we are looking at the first two columns. So true, true is true, true, true is true, true, false is false, true, false is false, false, true is false, false, true is false, false, false is true, false, false is true. Now we'll write down the second compound proposition and solve for those truth values. Now again, the biconditional statement means that if both truth values are the same, it'll be true. If they are different, it'll be false. So we're looking at the fourth column and the third column. So false, true is false, False, false is true. True, true is true. True, false is false. False, true is false. False, false is true. True, true is true. True, false is false. Now all together, we'll write P, biconditional statement, Q, inclusive OR, negation of Q, biconditional statement, R. Now inclusive OR is telling us that if both truth values of the compound propositions are false, it'll be false. Any other combination, the truth value is true. Now we're looking at the fifth and sixth columns. Now we see that true, false is true. True, true is true. False, true is true. False, false is false. False, false is false. Now you'll see that the next three are false, true, 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 and true, false. So they will all be true. True, true. So this would be the truth table for E. Now we'll do F. So let's get rid of some columns in order to solve for F. Now we know that F is given to us as the negation of P, biconditional statement, the negation of Q, biconditional statement, Q, biconditional statement, R. So by looking at this compound proposition, we see that we have 5 individual propositions. We have negation of P, that's 1. We need P to find the negation of P, so that's 2. We have the negation of Q, that's 3. Q, that's 4, and R is 5. So we have 3 written here. Now let's write down the other 2 that are missing, which is the negation of P and the negation of Q. So again, the negation of P truth values are the opposite truth values of P. So they are false, 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 true, 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 true. Same thing for Q. The negation of Q truth values are the opposite truth values of Q. So it's false, false, true, true, false, false, true, true. Now we'll write down the first compound proposition. So that's negation of P, biconditional statement, negation of Q. So again, the biconditional statement means that both truth values of each proposition needs to be the same in order to make it true. If they are different, it'll be false. So we're looking at the fourth and the fifth columns for this compound proposition. False, false is true. False, false is true. False, true is false. False, true is false. True, false is false. True, false is false. True, true is true. True, true is true. Now we'll write down the second compound proposition. So Q, biconditional statement, R. Now we're looking at the second column and the third column. So true, true is true. True, false is false. False, true is false. False, false is true. True, true is true. True, false is false. False, true is false. And false, false is true. Now all together, we have negation of P, biconditional statement, negation of Q, biconditional statement, Q, biconditional statement, R. Now, the truth value of this compound proposition and the truth value of this compound proposition, if they're the same, it'll be true. If they differ, it'll be false. So we're looking at the 6th and the 7th column. So true, true is true. True, false is false. False, false is true. False, true is false. False, true is false. False, false is true. True, false is false. And true, true is true. So this will be the truth table for F.